The Oracle database server saves the old value, undo data, when a process changes data in a database. It stores the data as it exists before modifications. Capturing undo data enables you to roll back your uncommitted data. Undo supports read consistent and flashback queries. Undo can also be used to rewind, flashback, transactions and tables. Read consistent queries provide results that are consistent with the data as of the time a query started. For a read consistent query to succeed, the original information must still exist as undo information. If the original data is no longer available, you receive a snapshot to old error or a 01555. As long as the undo information is retained, the Oracle database server can reconstruct data to satisfy read consistent queries. When a transaction starts, it is assigned to an undo segment. Throughout the life of the transaction, when data is changed, the original, before the change, values are copied into the undo segment. You can see which transactions are assigned to which undo segments by checking the $transaction dynamic performance view. Undo segments are specialized segments that are automatically created by the database server as needed to support transactions. Like all segments, undo segments are made up of extents, which, in turn, consist of data blocks. Undo segments automatically grow and shrink as needed, acting as a circular storage buffer for their assigned transactions. Undo segments can exist only in a specialized form of tablespace called an undo tablespace. You cannot create other segment types, such as tables, in the undo tablespace. The Database Configuration Assistant, DBCA, automatically creates a small file undo tablespace. You can also create a big file undo tablespace. However, in a high-volume online transaction processing, OLTP, environment with many short concurrent transactions, contention could occur on the file header. An undo tablespace, stored in multiple data files, can resolve this potential issue. Undo data and redo data seem similar at first, but they serve different purposes. Undo data is needed if there is the need to undo a change, and this occurs for read consistency and rollback. Redo data is needed if there is the need to perform the changes again, in cases where they are lost for some reason. Undo block changes are also written to the redo log. The process of committing entails a verification that the changes in the transaction have been written to the redo log file, which is persistent storage on the disk, as opposed to memory. In addition, the redo log file is typically multiplexed. As a result, there are multiple copies of the redo data on the disk. Although the changes may not yet have been written to the data files where the table's blocks are actually stored, writing to the persistent redo log is enough to guarantee consistency of the database. The Oracle database server provides automatic undo management, which is a fully automated mechanism for managing undo information and space in a dedicated undo tablespace for all sessions. The system automatically tunes itself to provide the best possible retention of undo information. More precisely, the undo retention period for auto-extending tablespaces is tuned to be slightly longer than the longest-running active query. For fixed-size undo tablespaces, the database dynamically tunes for best possible retention. The undo_retention initialization parameter specifies, in seconds, the low threshold value of undo retention. Set the minimum undo retention period for the auto-extending undo tablespace to be as long as the longest expected flashback operation. For auto-extending undo tablespaces, the system retains undo for at least the time specified in this parameter, and automatically tunes the undo retention period to meet the undo requirements of the queries. But this auto-tuned retention period may be insufficient for your flashback operations. Undo information is divided into three categories: uncommitted undo information, active, supports a currently running transaction, and is required if a user wants to roll back or if the transaction has failed. Uncommitted undo information is never overwritten. Committed undo information, unexpired, is no longer needed to support a running transaction but is still needed to meet the undo retention interval. It is also known as unexpired undo information. Committed undo information is retained when possible without causing an active transaction to fail because of lack of space. Expired undo information expired is no longer needed to support a running transaction. Expired undo information is overwritten when space is required by an active transaction. The default undo behavior is to overwrite the undo information of committed transactions that has not yet expired rather than to allow an active transaction to fail because of lack of undo space. This behavior can be changed by guaranteeing retention. With guaranteed retention, undo retention settings are enforced even if they cause transactions to fail. Retention guarantee is a tablespace attribute rather than an initialization parameter. This attribute can be changed only with SQL command line statements. You might have two reasons for changing the undo tablespace to a fixed size: to support flashback operations, where you expect future use of the undo, or to prevent the tablespace from growing too large. If you decide to change the undo tablespace to a fixed size, you must choose a large enough size to avoid the following two errors. DML failures, because there is not enough space to create the undo for new transactions. Snapshot too old. Errors, because there was insufficient undo data for read consistency. Oracle recommends that you run a regular, full workload allowing the undo tablespace to grow to its minimum required size. Temporary tables are widely used as scratch areas for staging intermediate results. This is because changing those tables is much faster than with non-temporary tables. The performance gain is mainly because no redo entries are directly generated for changes on temporary tables. However, the undo for operations on temporary tables and indices is still logged to the redo log. Temporary undo reduces the amount of undo stored in the undo tablespaces. Less undo in the undo tablespaces can result in more realistic undo retention period requirements for undo records. Temporary undo reduces the size of the redo log. Performance is improved because less data is written to the redo log, and components that parse redo log records, such as LogMiner, perform better because there is less redo data to parse. Temporary undo enables data manipulation language (DML) operations on temporary tables in a physical standby database with the Oracle Active Data Guard option. However, data definition language (DDL) operations that create temporary tables must be issued on the primary database. You can enable temporary undo for a specific session or for the entire database. When you enable temporary undo for a session using an alter session statement, the session creates temporary undo without affecting other sessions. When you enable temporary undo for the system using an alter system statement, all existing sessions and new sessions create temporary undo. When a session uses temporary objects for the first time, the current value of the temp_undo_ enabled initialization parameter is set for the rest of the session. Therefore, if temporary undo is enabled for a session and the session uses temporary objects, then temporary undo cannot be disabled for the session. Similarly, if temporary undo is disabled for a session and the session uses temporary objects, then temporary undo cannot be enabled for the session. $tempUndoStat shows various statistics related to the temporary undo log for this database instance. It displays a histogram of statistical data to show how the system is working. Each row in the view keeps statistics collected in the instance for a 10-minute interval. The rows are in descending order of the begin_time column value. This view contains a total of 576 rows, spanning a 4-day cycle. This view is similar to the $UndoStat view. You can view undo information on the Undo Management Details page in Enterprise Manager. Database Express. Undo generation rate displays the undo generation in kilobyte per second. Undo space usage shows the use of space in the tablespace. Steal activity breakdown shows the number of attempts to steal expired undo blocks from other undo segments and attempts to obtain undo space by stealing unexpired extents from other transactions. You can access the Undo Advisor in Enterprise Manager Cloud Control by performance greater than. Advisor's Home, Automatic Undo Management. The middle part of the General tab contains the Undo Advisor analysis. It provides an estimate of the undo tablespace size required to satisfy a given undo retention. Click Show Graph to see a graphical representation of the required tablespace size. You can click a point on the graph to see the tablespace size required to support the selected period. To change the undo tablespace to a fixed size, click Edit Undo Tablespace and then click Edit in the Data File section.